始まるかも。待って。そう。じゃあ12時になったら始めましょうかね、コーディングとか。
はい、わかりました。
はい。無事に始まった。じゃあ、やりましょうか。
はい。じゃあ始めますか。
はい。
はい、
お願いします。
それでは、株式会社マネーフォワードによる gRPC クライアント CLI ツール、名付けて gRP ケークの、ライブコーディングを開始したいと思います。よろしくお願いします。
よろしくお願いします。
お願いします。はい。まずちょっと今回の登壇者の自己紹介をしたいと思います。私は CTO 室 Web3 グループというところで、ブロックチェーンの機能の開発だったり、技術のリサーチに従事している宇治と申します。今日は、このイベントの進行役を務めさせていただきますので、よろしくお願いします。で、次に、今日のイベントをメインで進めてくれる2人のパーソナリティを紹介したいと思います。じゃあ、ファスティンさん、could you introduce yourself?
Yes. でもね、日本語で。
日本語。OK。
自分、ファスティンと言って、ナルトが大好きで、日本に来たのが 2015年です。マネーフォワードをジョインしたのは2022年で、それ以来、gRPC サービスを Go で書いています。よろしくお願いします。
お願いします。じゃあ、アンフィさん
Okay,
は、
so
okay. Could you introduce yourself?
Sure. So good morning, everyone. I'm Andy from Vietnam. So currently, I'm working for the Mikatano team for Money Forward. I'm currently working as a front-end developer, but I enjoyed working with Go in the past. So my hobby is playing Splatoon and sometimes play poker. よろしくお願いします。
はい。よろしくお願いします。今日は、このお二人にメインで進行していただきます。で、ちょっとまずイベントの説明をさせてください。今回のイベントは、そのタイトルにもあるコマンドラインから gRPC サーバーを、簡単に叩ける、テストできるっていうようなことを目的としたツール、gRP ケークと呼ばれる、ツールですね。のライブコーディングになります。で、このライブコーディングを見てもらうことで、視聴者の皆さんに Go だったり gRPC に関する、ツールの開発知見、あとは気づきっていうのを言ってもらうこと。あとは、マネーフォワードのプロダクト開発の雰囲気みたいなところっていうのを少し体験してもらうことを目的としております。で、マネーフォワードは、最近その英語化、開発組織の英語化に取り組んでまして、ちょっと今回のイベントに関しても、英語でちょっとコンテンツを提供するっていうのを取り組みとして行っています。なので、ちょっと本セッションは英語で行われます。ただ、そのコードを見せながら英語でやっていくので、英語があまり得意でない方でも楽しめるような内容になってるんじゃないかなと思ってます。で、質問は、YouTube のチャットにて、投稿いただけると、ファスティンさんだったり、自分が、YouTube の方で返信できればなと思ってます。英語でも日本語でも OK です。それでは、早速、ライブコーディングの方を始めたいと思います。アンディさん、Are you ready?
Yeah, let's go.
Let's go. お願いします。
Okay, so can you guys see my screen?
Yes.
Okay.
Okay. So good morning, everyone. Thank you all for being here today. So in this session, I want to share with you the step to build a gRPC testing tool. So throughout the session, we'll go through the definition and key features of gRPC. We'll build the testing tool. And after that, we'll have a small Q&A session. So by the end of the presentation, we hope that you will have a deeper understanding of Prorabuf, gRPC, and how to build a command line application. Okay, so as for the agenda, first, I'll give a brief introduction to gRPC. Then I will present the general ideas of the application that we're going to be building. So it's going to be gRPC cake. And next, we're going to build the app together. And finally, we'll have a small Q&A session. So first thing first, what is gRPC? So gRPC is an open source high performance RPC framework. It enables communication between clients and server applications, allowing them to invoke methods and exchange data seamlessly across different programming languages and platforms. So the key features of gRPC include multi-language support. So you can write your gRPC service using most popular programming languages like Java, Ruby, or Go. Next is interoperability. So gRPC service written in different languages and running on different platforms can communicate seamlessly. So this will make it easier to build a distributed system or microservice, and also make it easier to integrate a new service into an existing system. And finally, is high performance. So gRPC is built on top of the HTTP2 protocol. So it received all of the improvements and advantages of HTTP2. And furthermore, JBC uses protobuf as the main encoding method, which will reduce the payload size and increase the throughput. So JBC is often used to build distributed system or microservice. And more recently, it is used to connect mobile devices and browser clients to the backend service. Okay, now about JBC Cake. Oops. Let me go back. So JBC Cake is going to be a CLI application used for testing JBC endpoints. So it's going to be similar to CRL or HTTP for REST endpoints. So here's the features that we're going to add to JBC Cake. It should be able to invoke the unary JBC method. It should allow importing profiles or using the server function API. And finally, it should have a simple and intuitive UX. So here's a sample of JBC Cake. Okay, so without further ado, let's build it. So let me open my. Okay, so here I have a starter project. I have included a test server that we're going to use to test the various features of JBC Cake. So this test server will have a field profile that we're going to use throughout the session. Okay, so first thing first, let's create our main file. So I will define the main function. So what is the step needed in order to invoke a JBC method? So the first thing is we need to get some necessary information. And that includes the URL for our JBC server, the JBC method name, the path to our protobuf file, and finally, the request message as a JSON string. So I'll put it as JSON body. Okay, so after we have this information, we can go ahead and create a JBC client. So a JBC client is gonna be the one who holds the logic to send and receive data from the JBC server. And after we have initialized our client, we can just go ahead and send a JBC request. And finally, we will print the response to the SDV out. Okay. So first thing first. To get this information, I will require the users to pass in them as the command line flag. So I would define some string flag over here. So I will name this flag URL. The default value will be an empty string, and the help message will be the URL of the gRPC server. Next is going to be the method name, and it's the same. I'm going to name the flag gRPC method, and help message will be the gRPC method name. Next is the protobuf file path. I will name it import file. I will name the flag proto, and the help message. To protobuf file. Okay, and finally the JSON body. So the flag will be body. Okay, and it's gonna be a request message as JSON. And after we have defined our flag, we have to call flag.parse so that this variable is hydrated. So next, let's go ahead and define our JBC client. I will add a new struct over here. I will call it JBC client. So the first field it needs to have is going to be the JBC connection to the server. For this, I'm going to use the client connection interface from the gRPC package. Okay, and next we'll need a list of file descriptor. So we're going to use the type from the reflect package. Okay, so what is protobuf descriptor? So protobuf descriptor is essentially the representation of the protobuf element within the Go code. So if you take a look at a protobuf file, you can see that it has many elements like message, service, or method. So the descriptor will hold this information and allow us to use them to perform various operations. Okay, so for our case, using a list of file descriptor would work fine, but I would like to use this data type instead. So this is imported from the ProCompile package, and essentially it's still a list of file descriptor, just with some extra helper function. So let's go ahead and run from multi-tidy. Okay. So now let's create our constructor. I will call it new gRPC client from protofile. And it will take in the URL and the path to our protobuf file. It will return the gRPC client and some error. Okay. So first thing first, let's initialize our connection to the server. For this, I'm going to use the gRPC.dial method. So I'll pass in our URL. And since we're not supporting TLS at the moment, I will add an insecure transport credential right here. Okay. Then I will check for the error and return is not known. Okay. So next, we need to parse the protobuf file specified within this path. So for this, I will use the ProtoCompile package. So I will define a new compiler. So this compiler will take in a list of file name, and it will parse it and return us with a list of file descriptor. So for this constructor, we need to pass in the resolver. And we're going to use the ProtoCompile for source resolver. So the source resolver will help us resolve the import statement within the protobuf file, like this one and this one. Okay, so next I'm going to call compiler.compile. It takes in a context, so I will pass in the background context and the file name. Okay, so I will check for the error and return it is not known. Okay, now we can go ahead and return our gRPC client. We'll pass in the file descriptor and the connection. Okay, so let's go back to our main function and call this constructor. So we're going to call it new gRPC clients from profile. We pass in the URL and the file path. Let's check for the error. So if there's an error at this point, we will terminate the program. Error. Creating a gRPC client. Okay. All right. So next, let's implement a function to send the gRPC request. So I will go back to my gRPC client, and I will add a new method. And it's going to be invoke RPC. So this method will take a context, a fully qualified service name, a method name, and finally a JSON body as the parameters. And it's going to return us with a proto message and some error. Okay, let's save this. And oh, it's importing the wrong profile. Let me update that real quick. Code above proto. Yeah, so this is the correct one. Okay, so what is the step needed in order to invoke an unary RPC method? So first, we have to find the service descriptor. So next, we'll get our method descriptor, and we'll create a protobuf request message. And finally, we can invoke our unary RPC method. Okay, so let me put in a stop for this part. So I will call the function by service descriptor, and I will pass in the fully qualified service name. So you guys might be wondering, what is a fully qualified service name? So a fully qualified name is a name that uniquely identifies a protobuf element. Okay, so for the service name, its fully qualified variant is going to have this format. It's going to be the package name and the service name separated by a dot. So the fully qualified name of our basic service is basic.basic service. Let's go back to our main function and check for the error. Okay, now let's go ahead and implement the file service descriptor. So we will take in the service name, and it will return us with a service descriptor and an error in case we can't find it. Okay, so finding a descriptor is very simple. We can just call file descriptor and call file descriptor by name and provide our service name. So this method will look into our file descriptors and return a descriptor that match our service name. I will check for the error, and I will return our descriptor. But as you can see here, Go is giving us a warning. So that is because the data tag returned by file descriptor by name is just a regular descriptor, not a service descriptor. So we have to do some additional tag assertion. So I will assert this variable to the service descriptor. And if the assertion succeeds, no, does not succeed, then we will return from this function and give us an error. Error service not found. Okay, now that we can finally return our service descriptor. So let's go back to our invoke RPC function. So once we have our service descriptor, getting the method descriptor is pretty easy. You can just list the method and get one with the correct name. Okay, so for this method, if it can't find a matching method descriptor, it will return no, so we need to check for that as well. Error, method not found. Okay, now that we have our method descriptor, we can go ahead and create our pop-up request message. So to create the correct message, we can use the package dynamic pop-up from Google. So this package provides us with a function called new message. It will take in a message descriptor and return an empty pop-up message with the correct type. So now we want to create a request message. So we'll pass in the message descriptor for the input of this method. Okay. Then we unmarshal the content of our JSON string into this request message. And we will use photo JSON.unmarshal. And we'll pass in our JSON body and our request message. Let's check for the error. And return no and error. Okay. And one final thing, we have to create an empty response message beforehand so that when the data is returned from the gRPC server, it's going to get unmarshaled into the response message. So I will create the message for that as well. Okay, and finally, we can invoke our RPC method. And for that, we're just gonna call the invoke method of our connection. So it will take in a context and a specially formatted method string. So I will put it as empty for now. Next is the request and the response. This function will also return an error. So we'll check for that. And we will return the response. Okay. So about this formatted string. So the invoke method requires us to pass in a string that is formatted in this way. So it will start with a slash, then a fully qualified service name, and the method name separated by another slash. So we need to pass in a string of this exact format. You can actually verify this by going into the generated file from the protobuf, and you can see that they're using the exact same format. So I will create a helper function and pass in our method descriptor. Okay, so let's go ahead and implement this request method function. We will take in a method descriptor, and it will return a simple string. Okay, so for this, the implementation is quite simple. We can just use as printf and pass in the correct formatted string. Next, I will pass in the fully qualified name and the method name. Okay, so this parent method will return the parent elements of this descriptor, and that's going to be our service. Okay, now that we have implemented our invoke RPC function, let's go back to our main. So before we can call invoke RPC, we still need to do some more. So as you can see, the invoke RPC require the service name and the method name, but we're only getting one string for this from the command line. So that's because I wanted the user to pass in a formatted string of this format. So it's going to be very similar to the one from gRPC. It's going to be fully qualified service name and the method name separated by a slash. Okay, so we need to split the string to get our service and method name. First, let me call string.split, and I will pass in our gRPC method name and the separator as a slash. I will check for the length and we'll terminate the program if it's not correct or invalid method name. Okay. Then finally, we can extract our service name and method name from this parts array. Okay. And one final thing, because invoke RPC is calling to a remote server, it's best practice to have some kind of timeout. So I would define a new timeout context. I'll pass in the background context and the timeout as 15 seconds. So we'll call the cancel function. Okay, now we can finally start calling our invoke RPC method. So just gonna pass in the context we just created, the service name, the method name, and the JSON body. Okay, let's check for an error and terminate. Error and send to receive class. Okay, now let's go ahead and print the response to std out. I will marshal the response into JSON first for readabilities. So I will use the JSON.marshal function and pass in our response. So the return value will be response as JSON and some error. So we'll check for the error marshalling response to JSON. And finally, we can print it to our std out. Okay, so let's try it. First, I will run the test server. And I will run our main function. We'll run main.go. Next, I will pass in the URL, and it's going to be localhost 6069. Next, I'm going to pass in our gRPC method, and it's going to be this one. Basic service. slash unary example. Okay, so that is the method name. Next, I'll pass in the proto file. And it's going to be at internal testing. Okay, here. And finally, the JSON body. So I will pass in the integer field and string field just for reference. Then the string field will be hello go conference. And I will close this string. Okay, so let's try it. Oh, I forgot. So the main.go should be in the command folder. And as you can see, we have received a response from the server. So it's just the same as our body because it's just an equal server. Okay. So let's take a 5-minute break and we'll be back in around 12:37. Okay. Thank you, guys.
Okay, so at this point we have the simplest of the tools. So it can make a unary gRPC request, and it can take the request parameter as JSON, raw JSON, and it will print the response to standard output. Okay. So an interesting thing that we've seen is the dynamic PB. The dynamic PB, so which allows us to create dynamically messages of the appropriate type. Yes, and we've also learned about descriptors full name. Descriptors on the full name. Okay, so after this, we are going to try to read the request parameters as regular command line arguments. Is that the plan?
Yes, that is the plan.
Okay.
So after the break, we will update our UX so that it's more simple and intuitive. And finally, we'll add support for some more way to get our descriptor.
So there was a comment about about your editor showing the bang equal as the different symbol. Like for example, when you say if R is not nil,
okay,
you see the symbol.
Oh, like this?
Yes.
Yeah.
So
this like the features of the fonts that I'm using. So
yes.
The font I'm using is called Cascadia Code. So it's the default font for VS Code, and it's have this little font ligature. So yeah.
Yeah, so I was thinking your font and your editor must both support ligatures for this to be possible.
Yeah, I guess so.
Oh, we have a question. Events.
Yes, please go ahead.
So the question is, what is the main difference between these two and events CLI?
Event CLI?
Yes.
Let me open. So is this the one he was talking about? Event GitHub. Is this the one?
Yes, I think that's the one, yes.
Yeah, so personally, I think events is a more app-like, and the gRPC is more like command-based. So when you want to use event, you have to like go into a separate mode. But if you use gRPC, you can just start typing from like your terminal. So I feel like it's gonna be a bit faster.
Also, I think event CLI takes the input as JSON string, right? Even in the CLI mode. Like you cannot split the JSON.
I'm not too sure about that because I haven't used events yet. But looking at this screenshot over here, I suppose it has its own way to like define the data fields.
Yes.
So
basically, gRPC Cake is like a way to quickly just test your gRPC server.
Yep.
Without the way you are used to use command line tools. It's my command, my arguments.
Yes, that is correct.
Okay, so I think we can continue with the next steps.
Oh yeah, of course.
Okay.
Okay. So for the first part, we have implement an MVP. So we have been able to send a request and we have a response from our gRPC server. So next, I want to take a look at the command design a bit. So at the moment, we're requiring the user to pass in like a full JSON string for the body. But I think this is entering the full JSON string is a very frustrating and error-prone experience. So instead of this body flag, I want to allow the user to pass in each data field one by one. So it's going to be have this format, a string field equal to hello go conference, and integer field equal to like let's say 10. So this format will be easier to input and definitely less error prone. But there's still a problem with this design is that we do not know whether this 10 over here is a string or an integer. Yeah, so we have decided to use a different operator for like these data type. So instead of using equal, we use the colon equal for let's say raw data field. Yeah, so we're going to use the same one if we want to pass in, say, an array or a boolean. So let's try and implement this design. First, let's refactor the main code a little bit and move our gRPC client to a separate file. So I will create a new file called gRPC.client out here, and I will name the package gRPC. Okay, now let's update our imports. And go back to our main function. We will update this part to use our newly created package. Hold on. This one is rubber. Okay, we are having a small problem. Oh, got more tiny once again. And update our imports. Okay. Hey, Boston, what do you think might be the
We
problem?
don't need the second gRPC in main.
Oh, yeah, that's right. Yeah, I think that this should be good. Okay, let's try the last command. Oh. And hold on, let me put this somewhere else. And it's working as we expected. Okay, thank you, Boston. Okay, so to implement the new command design, we'll add a new function called parse argument. Okay, so this function will receive a list of arguments, and it will return us with a JSON string or an error if there is if they have like invalid format. So first, let me define my JSON string as an empty JSON, and I will also put the error up here. Okay, now let's look through our argument. And so first, let's try to process this type of argument here equal. Okay, so we'll split the string into two parts using this colon equal operator as the separator. So we'll check if the length of the part is correct. And if that's the case, then we can go ahead and update our JSON string. So I will call sjson.setRaw. So I'll pass in the key and the value. So sjson is a package that allows you to work with JSON string directly. So for this command, we're setting the key of this JSON to the raw value of this part. Now we'll check for the error. Return it if necessary. And finally, we will continue with the other argument. Otherwise, if we cannot split the string using this operator, we will try to use the equal operator. Now, If the length of the part is not equal to 2, then we can assume that the users have entered an invalid argument. So we will return an error, and error invalid argument received. Okay. So otherwise, we'll update our JSON string. And we'll call set to set this key to the string representation of our value. So I'll check for the error. And I will return from this function. Okay. So we still want to let user pass in a full JSON string if they want. So I would do a check to see if the JSON body is empty. So if it's empty, then we will parse the argument. So if it's empty, I will call parse argument with the non-flag argument. Oh, we need to define the error up here and check the error. We'll terminate the program up here, error invalid argument. And I'll pass it the error. Okay, so let's try that again. So I will remove the body flag. And I will pass in string field equal to hello, and the integer field equal to 10. We have to install this package first. And let's try that again. And it is working as we expected.
Nice.
Nice. Okay, so next, let's go ahead and add support for the server reflection API. Okay, now we will take a look at our gRPC client. We are getting our service descriptor from our file system, from our protobuf file. So the server reflection API is special. It's a kind of special gRPC API that allows the client to query what method and service that a server can process. Okay. So instead of getting it from the protobuf file, you can get it from the actual server itself. But now, if we take a look at our implementation of gRPC client, we're seeing that it's depending on the file descriptor. So to extend our capabilities to support server reflection, we will add a new interface. And we'll call this interface descriptor source. And this interface will have one method that's called by service descriptor. And it would take in a fully qualified service name and return a service descriptor. Okay. So now let's decouple this logic from our gRPC client. So I will define a new descriptor source, call file source. Okay, and it will have the file descriptor as the struct field. Next, I will implement this interface. By copying this logic from gRPC client. Next, we'll add a new constructor for this descriptor source. I'll call it descriptor source from proto file. And it will take in a file path. File source and error. Okay, so we can just copy our logic from the gRPC client's constructor into this new constructor. Okay, so now let's return our file source and a new error. Okay, now let's make some change to our gRPC client. Let's remove this logic and add a new field called descriptor source. So we will remove these parts for parsing probe files, and we will call the new constructor that you just created, and we'll pass in our import file. Okay, so let's go ahead and also remove this function. Okay, so we'll update this file descriptor function to using the one from our descriptor source. Okay, now let's try this again. And it seems to be working pretty well. Now let's add support for server reflection API. So I will define a new source called server source. Okay, and it will have a single client field with the tag of gRPC reflect client. So gRPC reflect is a package that helps us handle like sending and receiving data from the reflection API. Now we'll implement this server source. Now let's generate the stuff. Return source. Okay. So to resolve the service name for our server source is very simple. We can just call the result. Oh, we have to install this package first. And we can call our resolve service function. We'll pass in our service name and check for an error. And finally, we will return our service descriptor. But as you can see, Go is giving us a warning that this is not the correct tag. So the reason for this is gRPC reflex is written a long time ago before the existence of this data type. So they have to implement their own version of service descriptor. But luckily, the author provides us with a handy little function to translate their service descriptor into the correct one. Okay, so there's one more thing that we have to keep in mind, that not all servers support the reflection API. Therefore, we need to check if a server supports it and tell our user if it doesn't. So I would check this error to see if the server actually implements this API. So I will wrap it with check reflection support method, and I will implement it over here. It will return an error. So first, we'll check if the error is no, then we can just return it. Otherwise, we want to call the status from error function to check if this error is from our gRPC server. And if it is, we'll check if the code is equal to unimplemented. Okay, so that means our server does not support this API. If so, we'll return a new error that our server does not support reflection API. Okay, and finally, if it is not from our server, we'll just return the function. Okay, now let's add constructor for server source. Scripted source is from server. So this one will take in a gRPC connection as the parameters. So I'll pass in the client connection interface, and it will return the server source. Now we can just initialize our client by calling gRPC reflect dot new client auto and pass in our connection and the context as well. Okay, so this new client auto method will check what version of the API that our server supports and create the corresponding client. Now we can just return our server source. Okay, let's go back to our gRPC client and add a new constructor. I'll call it new gRPC client from server. So this one will only take in the URL. The logic will be similar to the one from profile. Okay, let me copy this. But we will update this function and use the constructor we just created instead. So I'm going to call descriptor source from server and pass in our connection. Okay, and let's return to our main.go file. So we want to check if the user passes in the path to the probe file or not. So if the user doesn't, we will use the server reflection API. And we'll check if it's empty, then we will create our files using the server reflection API. I'll pass in the URL. I will add a new declaration over here. And otherwise, we can call the old function. Okay. So let's test this feature. Let's go back to our command. And now I will remove the probe file. I press enter. And we are receiving an error. So it's saying that the server does not support the reflection API. So as I say, if we want to support this API, we have to explicitly enable it within our server. So I will go to my test server and I will add the function to enable this API. So I will call register and pass in my JVC server. I will rerun the test server. And let's try again. And it's working very well. Cool. So finally, we'll add one small feature. So until now, we have only been testing the example proto from our basic package. Now let's try the one from the advanced and the composite. So first, let's try this one. Let me close this tab. Okay, so let's change the import path from the basic package to the advanced package and update our JSON method. Advanced service. Okay. Now we will update our field name. Okay, so I'll change this and press enter. And now you see that we are receiving another error. And this one is saying that it can't find this timestamp.proto and duration.proto file. So if we think about it, it's very reasonable because our resolver doesn't have any information about where this file is or what are their content. So to fix it, we have to go back to our descriptor source and take a look at our compiler declaration. Sorry. Okay, so we're using the default source resolver. If we want to add support for the standard Google library, we need to wrap it with this function. So this with standard imports function will return a new resolver that knows about the standard Google library. So if we try sending the command again, we can see that it has success. Okay. And finally, let's try our composite file. Composite service. And I will pass in the correct file path. Okay. And we'll press enter. And we'll have the same error. For this file, instead of importing from the standard library, we're importing a file in the same project. So the default behavior of our resolver is that it's going to start looking for this file from the current directory. So for this file, it will start looking in the basic folder. And that's not what we want. So we need to provide a way so that the user can customize this path. So let's go back to our descriptor source function. And now we will add a new variable called import path. So the import path will be the path that your proto file is in so that the resolver can successfully resolve the file name. So I will add a new parameters for this constructor. Okay, now I will go ahead and update all of the parents function. Okay, we have the import paths over here. And let's go back to our main function. Here, we will add a new flag. So we will allow the user to pass in multiple import paths separated by a comma. So I will define a new string flag. Import paths for protofiles. Okay. Then over here, I will define a new variable called import paths, and it's going to be a list of string. So we'll check if the user passes in import path flags, and we will split it into this variable. In the split, and put this in, and we'll use the comma as the separator. Then we can just pass our import paths into this function. Okay, so let's update our command. First, let's add the new flag we just created. So our proto file is in the internal /testing/proto folder. So that's what we want to pass in for this variable. And now, since it's already passed the import path, we don't need to specify it again in the proto flag. Okay, now let's press enter. And we are having an error. Let me see. This one, import path, that's correct. This proto is correct. Proto, let's just file.
So is it trying to look for composite example.proto from internal testing proto?
Yes, that is correct. Maybe. Oh, okay. So I specified the condition wrong. So if the import path is not empty, then we do a split.
Oh,
And now if we try to run the command again, then we can see that it is working as we expected. So this is the end of our session. Thank you everyone for attending. Next, we'll have a small Q&A session. So if you have any question or comment, we would love to hear about it. Thank you, everyone.
okay. Thank you very much, Andy, for your presentation.
Thank you, アンディさん、ファンスティさん。じゃあ、クロージングに入りたいと思います。お二人ともありがとうございました。で、今回のイベントはアーカイブを、後ほど公開する予定ではありますので、ちょっとまた見返したいという方がもしいらっしゃれば、ちょっと後ほど案内すると思うんですけど、URL から見ていただければなと思います。で、 行動に関しても公開できればしたいなと考えてますので、そちらもちょっとお待ちいただければなと思います。で、ちょっと最後にこのイベントの他のアクティビティの紹介もちょっとさせていただきたいなと思ってます。で、まず登壇情報なんですけど、弊社から2人、Goカンファレンスの、メインのセッションの方にて登壇の予定があります。グプタハーシュさんという、グローバルメンバーの一人なんですけれども、Go のエスケープ解析についてのセッションを、3時20分頃からしていただきます。で、次にその自分なんですけど、Go のブロックチェーン領域の話っていうのを4時半からやりたいと思ってます。どちらもショートトークなので、気軽に参加いただければなと思います。で、さっきちょっとお話しいただいたんですけど、3時から4時の間、マネーフォワードのブースにて、アンディさん、ファッシンさんお二人に来ていただこうと思ってます。で、もし質問とか、英語でお話ししたいみたいなことがあれば、ちょっとこの時間帯を狙って来ていただけるとお話できるかなと思いますので、よろしくお願いします。で、最後に、ちょっと今日のアクティビティじゃないんですけど、6月の15日にマネーフォワード、カンム、ミラティブ、ナレッジワークの4社、Go カンファレンスのスポンサー4社なんですけど、この4社で、アフターパーティーっていうものを非公式で開催予定となってます。こちらのイベントで各社のエンジニアが、LT しつつ、あとは Go カンファレンスの感想戦っていうのを実施するので、こちらもぜひ参加いただければなと思います。はい。それでは、今回のイベントはこれにて終了したいと思います。皆さん、長い時間お聞きいただきありがとうございました。
Thank you for attending.
Thank you for attending, everyone.
ありがとうございます。じゃあ、おしまいにしましょうかね。我々も。
はーい。
はーい。じゃあ、配信を止めます。